Let's begin with that last lingering image, that final faint pinprick of light against the black. It was the interstellar visitor we named 3E Atlas. For a brief fleeting moment, our solar system, our home, had a guest from the great beyond. It was a tourist, a traveller, a tiny silent fragment of rock and ice that had journeyed for perhaps millions or even billions of years through the silent cosmic ocean. It came from somewhere else. It was a whisper from another world, a message in a bottle tossed into the void, and by pure chance it washed up on our shore. We watched it come. We tracked its path as it swung around our sun, feeling the warmth of a star that was not its own. And then we watched it leave, flung back out by our sun's immense gravity, continuing its endless journey into the immense silent dark. It was a remarkable moment, a scientific curiosity, of course, but it was more than that. As it vanished, as our most powerful telescopes strained to catch its very last photons of reflected light, it left us with an almost tangible sense of loneliness and a profound, echoing question. Where did it come from? That is the question that hangs in the air long after the visitor itself has gone. We don't know. We will never know, not with perfect certainty. We cannot trace its path backward through the complex dance of the stars. We can't rewind the clock for millions of years to see which star in which distant constellation threw this tiny piece of itself out into the dark. Was it violently ejected during the chaotic birth of a solar system just like ours? Was it the ancient frozen remnant of a collision between planets we will never see? Was it shaken loose from a cloud of comets orbiting a star that has long since died? We are left only to wonder, but here is the truly staggering thought. While we do not and cannot know the specific star it came from, its precise street address, we know with absolute certainty the kind of place it came from. It came from a home. It was not born in the cold, empty void between the stars. It was born with a star. It began its life in a place of gravity and light and matter. It was part of a system, a family of objects orbiting a parent sun. It proves in the most direct way possible that our solar system is not unique. It tells us that other stars have systems, other stars have debris, other stars have a story. It came from another house in our same cosmic neighbourhood. It proves we are part Tau, a vast, sprawling and impossibly large city, a great glittering city of stars. To truly understand this, we need to change our perspective. Let's try a thought experiment. Let's imagine just for a moment that we could hitch a ride on 3E Atlas as it leaves us behind. Imagine we are standing on its icy surface, wrapped up against the cold of deep space, and we are looking back. What do we see? At first, our beautiful blue Earth shrinks. It becomes a shining marble, then a bright blue dot, and then very quickly it is lost completely in the blinding glare of our sun. The other planets, our neighbours, fall away. Mighty Jupiter ringed Saturn. Their grand orbits become nothing but tiny, faint loops of light. And then our sun itself, the star that gives us life, the centre of our universe, the god of our sky, begins to dim. It shrinks. It becomes just another star. A very bright one for a while, but still just a single point of light among many. We keep going, racing past the outer planets. We cross the Kuiper belt, the realm of frozen worlds like Pluto. We fly farther still for thousands of years, until we pass the Oort cloud, that vast invisible sphere of dormant comets that marks the true final edge of our sun's gravitational kingdom. We are now truly in interstellar space, the space between the stars. Our entire solar system, our home, is now nothing more than a single faint speck of light in the darkness behind us. Then even that speck is gone. And as our eyes adjust to this new, deeper darkness, something astonishing happens. Something we can never ever see from the surface of our planet. We are no longer just looking at the individual trees. For the very first time, we are finally truly seeing the forest. We are outside looking in, and what we see takes our breath away. It is not empty. The blackness is filled with a structure. A vast, swirling, organised structure of light, dust and gas. In every direction we look, we are surrounded by a glowing ethereal fog. When we are on Earth, on a perfectly clear night far from the light pollution of our cities, we can see a faint shimmering band of light stretching across the entire sky. The ancient Greeks called it the Galaxias Kyklos, the Milky Circle. The Romans called it the Via Lactea, the Milky Way. It's beautiful, but from Earth it looks distant. It looks like a painting on the ceiling of the world. But from out here, from our imaginary ride on that departing visitor, we see the truth. It is not a painting, it is not a distant object. It is a place. We are inside it. This is the Milky Way. This is our home. We see a gigantic spinning disk of stars, a breathtaking spiral. It has great sweeping arms of light arms made of billions and billions of younger, bluer stars. Our sun is just one of them, a tiny, insignificant spark lost deep inside one of those arms. In the center of the disk, we see a brilliant glowing core, a dense, crowded bulge of billions of older golden stars so tightly packed that they merge into a single magnificent ball of light. And hidden in the very heart of that light, we know there is a monster. A supermassive black hole 4 million times the mass of our sun, holding this entire city together with its invisible grip. This is our cosmic island. Everything we have ever known is inside this structure. Every human who has ever lived, every animal that has ever roamed, every war ever fought, every poem ever written, every grain of sand on every beach, all of it is contained on a tiny speck of dust, our Earth, which is orbiting a very average star, our sun. And that sun is just one of an estimated 200 to 400 billion other stars. All of them, all of those billions of suns are bound together by gravity. All of them are swirling in a slow, majestic dance around that central core, a dance so vast that it takes our sun over 200 million years to complete just one single lap. This is the city. 3i Atlas was a visitor from another part of this city, or perhaps from another city altogether, so far away we cannot even imagine it. But seeing our home from this perspective changes everything. It connects us. That lonely rock, that fleeting visitor, wasn't just a scientific curiosity. It was a bridge. It was a messenger that forced us to lift our heads to look beyond our own fence. It forced us to see the magnificent, sprawling and impossibly large home that we all unknowingly share. It bridged the gap in our minds, the gap between being a resident of a single tiny planet and finally becoming a citizen of the galaxy. On a perfectly clear night far away from the glow of city lights, you might see it. It's not a cloud and it's not a trick of your eyes. It is a faint shimmering band of light, a glowing river of silver dust stretching from one horizon to the other. This is the Milky Way. For thousands of years, humans have looked up at this ribbon of light telling stories about its origin. The ancient Greeks called it a river of milk. But we now know what this beautiful ghostly light truly is. It's a view from our backyard. We are inside a giant city of stars, and when we look up at that band, we are not looking out into deep space. We are looking across our own city toward its brightest, most crowded downtown. The light we see is the combined glow of billions of stars, each one so far away that our eyes cannot pick them out individually. Their light blends together to create that soft, milky glow. This is our home. But to understand it, we must first imagine leaving it. If we could fly in a spaceship traveling up out of the flat disk of our star city, and look back, what would we see? We would see one of the most beautiful sights in the universe, a giant spinning wheel of light. We would see a spiral galaxy. It would be a vast flat pinwheel, brighter in the middle and slowly turning in the silence of space. This wheel is made of stars, not millions, not even billions, but an estimated 200 to 400 billion stars. It's also filled with enormous swirling clouds of gas and dust, the raw materials for making new stars. This entire structure, our home city, is called the Milky Way Galaxy. Like any great city, it has different neighborhoods, each with its own character. At the very center is the core, or the galactic center. This is the downtown district. It is a brilliant, blazing, crowded place. In this central bulge, billions of stars are packed incredibly close together. If we lived there, the night sky would be a solid wall of light with thousands of stars shining as brightly as the planet Venus does in our own sky. The stars here are mostly old. They are ancient senior citizen stars, many of them red and yellow, that have been orbiting the center for billions of years. This core is a place of old light and immense density. And at the exact very center of it all, at the heart of the city, lies a secret. It is a sleeping giant. Astronomers call it Sagittarius A star, pronounced Sagittarius A star. It is a supermassive black hole. Now, when we hear black hole, we often think of a terrifying monster, a cosmic vacuum cleaner sucking up everything in its path. But that's not the right way to think about Sagittarius A star. It is better to think of it as a gravitational anchor. It is not a thing in the way a star or planet is a thing, but rather a point of incredible, unimaginable mass. It weighs as much as 4 million of our suns, all crushed into a point smaller than our own solar system. It is this immense weight that holds the galaxy together. It is the anchor in the center of the spinning wheel, and its gravity is the heartbeat that keeps all 400 billion stars in a slow, steady cosmic dance. It is quiet. It sleeps. It only eats the occasional bit of gas or a stray star that wanders too close. For the most part, it is the silent, heavy heart that gives our galaxy its order. Moving out from the bright, crowded center, do we find the suburbs? These are the spiral arms. These arms are the main streets of our galaxy, long curving bands that wind their way out from the center. This is where we live. Our solar system is located in a smaller partial arm called the Orion Arm, nestled between two of the larger arms. Unlike the core, which is full of old stars, the spiral arms are where the action is. They are the cosmic nurseries. The arms are not solid, they are like giant traffic jams in space. As clouds of gas and dust drift through the galaxy, they run into these slower moving spiral arms and get squeezed. When you squeeze a giant cloud of gas, it collapses under its own gravity. The center of the cloud gets hotter and hotter until ignition, a new star is born. The spiral arms are where new stars are being born right now. This is why they are so beautiful. They are studded with bright glowing nebulae, the star nurseries, which shine pink and blue from the light of the hot young newborn stars within them. Our neighborhood, the Orion Arm, is a relatively quiet and peaceful place. It's not too crowded, but it's not empty either. It's the suburbs, a good place to raise a family of planets. This brings us to our own address. We are not in the center. And this is perhaps the most important fact about our home. We are located in a peaceful, quiet part of the suburbs. Our sun is about 26,000 light years away from the chaotic radiation-filled core. This distance is a blessing. If we were closer to the center, the gravity from all those packed-in stars would pull our solar system apart. The radiation from exploding stars' supernovae, and from the sleeping giant black hole when it occasionally burps, would be so intense that it would sterilize our planet. Life, especially complex life like us, could never have survived. If we were too far out on the very edge of the galaxy, there wouldn't be enough stuff. The stuff is elements like carbon, oxygen, and iron. These heavy elements are the building blocks of planets and people. They are forged inside stars and spread through the galaxy when stars die. Out on the edge, there haven't been enough generations of stars to create these materials. We live in the galactic habitable zone. It is a just right spot. It's stable, it's quiet, and it's rich in the materials needed to build rocky planets and the chemistry of life. Our position in this quiet arm is what has allowed Earth to remain peaceful for billions of years, giving evolution the time it needed to turn simple cells into thinking, wondering creatures. We are lucky. The single best way to feel the scale of our home is to think about time. The fastest thing in the universe is light. It travels at an incredible 300,000 kilometers or 186,000 miles per second. Our city, the Milky Way, is about 100,000 light years across from one side to the other. This means that a beam of light, the fastest thing there is, would take 100,000 years to travel from one edge of our galaxy to the other. Think about that. When you look up at the night sky and see a star on the far side of our own galaxy, the light that is hitting your eye tonight left that star 100,000 years ago. What was happening on Earth 100,000 years ago? Our ancestors, modern Homo sapiens, were just beginning their first great migrations out of Africa. They were walking the plains, looking up at the same stars, but they had no idea that the light from one of those stars had just begun its long journey. That single ray of light travelled through space as humanity learned to build fires and use complex tools. It travelled as the first artists painted on cave walls. It travelled as ice ages came and went, as agriculture was invented, as empires rose and fell, as pyramids and great walls were built. It travelled for 100,000 years past all of human history, and then tonight it finished its journey by entering your eye. This is the scale of our home. We are not just looking at stars, we are looking back in time. The light from the centre of our galaxy is 26,000 years old. The light from our nearest star after the sun is over 4 years old. We are all residents of this vast, ancient, spinning city of light. Our entire solar system, our sun, our Earth, and everything we have ever known is just one tiny, tiny speck of dust drifting in a quiet suburban arm of a grand river of light. For centuries, we believed our journey was complete. We had mapped the solar system and even begun to understand the vast shining river of stars we called the Milky Way. We floated inside this colossal city of stars, and as far as anyone knew, it was the only city. The entire universe was contained within its glowing boundaries. But what about those strange, fuzzy patches of light astronomers noted in their telescopes? They were faint, blurry, and looked like little swirls of smoke. For a long time, the consensus was that they were spiral nebula, clouds of gas inside our own Milky Way, perhaps new solar systems in the process of being born. This was the great debate of the early 20th century. Was the Milky Way the entire universe, or was it just one island of stars in a much larger, darker ocean? The question hung in the air, waiting for someone with a big enough telescope and a brilliant idea to answer it. The man who discovered the universe. That person was an American astronomer named Edwin Hubble, In the 1920s, working at the Mount Wilson Observatory in California, he had access to the most powerful telescope on Earth, the 100-inch Hooker telescope. He pointed this giant eye toward one of the most prominent spiral nebulae, a fuzzy patch in the constellation Andromeda. Hubble was looking for something specific, a special kind of star called a Cepheid variable. These stars are a gift to astronomers. They have a natural rhythmic pulse growing brighter and dimmer over days or weeks. Decades earlier, an astronomer named Henrietta Leavitt had discovered their secret: the faster a Cepheid pulses, the brighter it actually is. This meant Cepheid stars could be used as cosmic measuring sticks. If you could find one, you could measure its pulse. From the pulse, you'd know its true actual brightness, its wattage. Then you could compare that to how dim it appears in your telescope. From that difference, you could calculate its distance. Night after night, Hubble scanned Andromeda. And then he found one. He recorded its pulse, he did the math, and his answer must have made his blood run cold. The numbers didn't say the star was thousands of light years away, nestled comfortably inside our Milky Way. The numbers said it was nearly 1 million light years away, later revised to the modern value of 2.5 million. This was revolutionary. This cloud was not inside our galaxy. It was impossibly, staggeringly far outside of it. It couldn't be a cloud of gas. To be visible at all from that distance, it had to be colossal. It had to be another galaxy. In that moment, the universe didn't just get bigger, it shattered. The Milky Way was not the universe. It was just one island universe, as Hubble called them, in an ocean of billions of others. We were not alone. Our ghostly neighbour. That fuzzy patch, the one Hubble proved was a separate galaxy, is the Andromeda Galaxy. It is our closest large galactic neighbour, and it holds a special place in our sky. On a very dark, clear night, far from the glare of city lights, you can see it with your own eyes. You don't even need binoculars. It's not a sparkling star. Instead, it looks like a faint ghostly smudge, like a fingerprint on the blackness of space. When you find that smudge, take a moment to think about what you're seeing. The light that is entering your eye tonight left the Andromeda Galaxy 2.5 million years ago. That light has been travelling through the cold vacuum of intergalactic space ever since long before modern humans evolved. You're quite literally looking millions of years into the past. It is the farthest object a human being can see without the aid of a telescope. Andromeda is a majestic spiral galaxy, much like our own Milky Way. In fact, it's our big sister. While our Milky Way contains an estimated 200 to 400 billion stars, Andromeda is even larger, containing perhaps 1 trillion stars. It's a sprawling, magnificent city of light, just visible as a faint whisper across the vast dark emptiness. The cosmic dance. These two great galaxies, the Milky Way and Andromeda, are not just sitting still. For billions of years they have been circling each other, bound together by the invisible, unyielding force of gravity. While most galaxies in the universe are moving away from us as space itself expands, Andromeda is a special exception. It's heading right for us. Now, when you hear galaxy collision, you might picture a violent, explosive catastrophe like two cars in a head-on crash. The reality is something far more graceful and strange. This event isn't a collision so much as a gravitational waltz. It's a slow, majestic dance that will begin in about 4.5 billion years. Here is the most important thing to understand: the stars will not collide. Space is almost entirely empty space. The distances between stars are so vast that the stars themselves are like single grains of sand separated by miles of desert. While Andromeda has 1 trillion stars and we have hundreds of billions when the two galaxies merge, the chance of any two stars actually hitting each other is practically zero. So what will happen? The two galaxies will begin to pass through one another. From a distance, it would look like two ghostly swarms of fireflies intermingling. An observer on a planet inside this merger wouldn't be destroyed. They would just see a night sky suddenly filled with trillions of new stars. As the galaxies merge, their giant clouds of interstellar gas and dust will collide. This will compress the gas, triggering a spectacular galaxy-wide burst of star formation. The sky will light up with the birth of billions of new bright blue stars. Gravity will twist and pull the two spiral structures. They will pass through each other, swing far apart, and then, like a pendulum, be pulled back together again. This waltz will repeat a few times over hundreds of millions of years. With each pass, their beautiful spiral arms will be scrambled and torn apart. The two distinct galaxies will lose their shape and eventually settle into one single enormous combined galaxy. Astronomers sometimes call this future creation Milkomeda, or Milkdromeda. It won't be a pretty spiral anymore. It will likely be a giant elliptical galaxy, a massive roundish blob of stars glowing with the golden light of its trillions of aging suns. This is our distant and surprisingly peaceful future. It's not an end, but a transformation, a story of creation, not just destruction. The local group. Our cosmic village. Hubble's discovery showed us that Andromeda wasn't the only other galaxy. The darkness is filled with them, but Andromeda and the Milky Way aren't just two random galaxies floating in the void. They are the two largest members of a small, cozy cosmic village. This neighborhood is called the local group. It is a collection of more than 50 galaxies. The number keeps growing as we find smaller ones all bound together by their mutual gravity. They are all moving through space together as a single family. If the Milky Way and Andromeda are the two big cities in this group, the rest are like small towns and tiny villages. The third largest member of the Triangulum Galaxy is a smaller spiral. The rest are mostly dwarf galaxies, which are small, faint collections of just a few million or a few billion stars. Our own Milky Way has its own set of satellite villages orbiting it. The most famous of these are the Large and Small Magellanic Clouds. Visible only from the southern hemisphere, they look like two bright detached pieces of the Milky Way hanging in the sky like celestial clouds. They are small irregular galaxies on a long slow journey to be absorbed by our own. Andromeda has its own entourage of at least 20 dwarf galaxies orbiting it too. This entire village are Milky Way Andromeda Triangulum, and all their dozens of tiny satellite followers spans a region of space about 10 million light-years across. And so we find ourselves in a place that is both unimaginably vast and strangely intimate. We are not the entire universe. We are not even the only city. We are one bright island in an ocean of islands, a member of a local family, all bound together by gravity, drifting through an ocean of darkness that is far larger and more wondrous than we ever dared to imagine. Let us continue our journey. We have explored our home, our planet, our star, and even the cluster of galaxies we belong to. We have stayed within the relative comfort of our local neighborhood. Now we must take the final, most dramatic step back. We are going to zoom out so far that our entire galaxy, the Milky Way, becomes a single point of light, and even our entire local group of galaxies merges into an insignificant speck. We are pulling back to see the grandest possible structure, the true architecture of the cosmos itself. What we find is not a random spray of stars or a uniform soup. What we find is a pattern so vast, so intricate, and so empty that it challenges our very understanding of place and existence. We are about to see the universe as a living network, and at the same time we will confront the most profound mystery of all, a vast, dark and silent ocean that holds all of this and us in its invisible grasp. When we look at the largest maps of the universe ever created by humanity, maps that plot the locations of millions of galaxies, one staggering fact becomes clear. Galaxies are not spread out randomly. They are not like sand scattered on a beach. Instead, they are organized. They are drawn together by the relentless, patient hand of gravity, which has been sculpting the universe for over 13 billion years. The pattern they form is known as the cosmic web. Imagine a three-dimensional spider web glowing in the dark. The threads of this web are immense glowing filaments of galaxies' chains of light, stretching for hundreds of millions of light years. These filaments are like cosmic superhighways, rivers of matter flowing through the emptiness. They twist, they braid, and they connect, forming a structure that looks astonishingly like a network of neurons in a brain or the branching of capillaries in a body. These filaments are the stuff of the universe. They are where the action is. They are made of thousands upon thousands of galaxies, all trapped in a long, thin, gravitational stream. But they are also filled with something else. A vast, unseen reservoir of gas, mostly hydrogen, that streams along these intergalactic bridges. This gas is the lifeblood of the cosmos, the raw fuel that rains down into the galaxies, igniting the birth of new stars. So when we see these glowing threads, we are not just seeing the galaxies that are already on, we are seeing the plumbing, the delivery system that keeps the universe fertile and alive. And where these filaments cross, where the great cosmic highways meet in a major intersection, we find the cities. These are the most massive structures in the universe, the superclusters. A supercluster is a monstrous collection of galaxy clusters, a dense gravitationally bound knot containing thousands of galaxies like our own Laniakea supercluster. These nodes are the brightest, most crowded and most violent places in the cosmos. But they are only bright because they are fed by the long, dark and winding filaments of the cosmic web. This web connects everything. A galaxy in one filament is fundamentally linked by gravity and history to a galaxy a billion light-years away in another. It is the largest single structure we know of a shimmering interconnected pattern that forms the very skeleton of reality. However, the web's design is defined as much by its threads as it is by the spaces between them. The most striking feature of the cosmic web is not just the filaments, but the staggering, almost unbelievable emptiness that they enclose. These are the voids. If the filaments are the threads of the spiderweb, the voids are the vast, empty gaps in between. If the superclusters are the bustling, bright cities, the voids are the darkest, most profound deserts you can possibly imagine. These are not just empty in the way we think of an empty room. They are regions of space hundreds of millions of light-years across that are almost completely devoid of matter. They are the places that lost the gravitational lottery. In the early universe, when matter was first clumping together, the areas that had slightly more matter began to pull in everything around them. This matter collapsed to form the filaments and clusters. The voids are what was left behind. They are the regions from which all the matter was drained, floating away to build the bright structures elsewhere. The scale of this emptiness is terrifying. You could cross a void at the speed of light and travel for 200 million years or 300 million years and encounter almost nothing. The density of matter inside a void is less than 1/10 of the average density of the universe. A void galaxy, one of the rare profoundly lonely galaxies that happens to exist inside one, would have an entirely different view of the sky. An astronomer in a void galaxy would look out and see an almost perfectly black, unchanging universe. The nearest neighbouring galaxies would be the tiny, faint smudges impossibly far away. The great glowing streams of the cosmic web would be invisible, a distant rumour of light on the far horizon. This is where the universe reveals its dual nature. We live in a cosmos that is at the same time impossibly crowded and impossibly lonely. The filaments are packed with energy, light and interaction, while the voids are defined by an ancient cold and echoing silence. The universe, it turns out, is mostly nothing. The bright web we see, all the galaxies and stars we have ever studied, is just a delicate tracery, a fragile network of light, stretched thin over an ocean of profound darkness and quiet. This entire immense structure, the glowing filaments and the dark voids, is not sitting still. The entire tapestry is in motion, but it's a motion that is completely counterintuitive. It is not that the galaxy clusters are flying through space like shrapnel from an explosion. Instead, the story of the universe's motion is the story of the expansion of space itself. The Big Bang was not an explosion in space, it was the beginning of the expansion of space. The best way to understand this is the analogy of a balloon. Imagine you take a balloon and before you inflate it, you draw little dots on its surface. Each dot represents a galaxy. Then you start to blow up the balloon. What happens? The dots themselves are not moving across the rubber surface, but from the perspective of any single dot, all the other dots are moving away from it. And the dots that were already further away on the other side of the balloon move away faster than the dots that were close by. This is exactly what we see in the universe. When we look out at distant galaxies, we see that they are all moving away from us. This is not because we are special or at the centre of the universe. It is because the fabric of space-time, the very rubber of the balloon, is stretching everywhere all at once. Every galaxy would see the exact same thing, all its neighbours are moving away. This expansion is the grand narrative of our cosmos. It is what has been happening for 13.8 billion years. Gravity, as we saw in the cosmic web, tries to pull things together locally. It builds the filaments and the clusters, but on the grandest of scales, this mysterious expansion is working to push things apart. For a long time, astronomers thought this was a simple battle, gravity pulling and expansion pushing out. We assumed that gravity would eventually win or at least slow the expansion down, perhaps even causing the universe to collapse back on itself in a big crunch. We were wrong. The story it turns. Out is far stranger and far darker. This brings us to the final and most profound part of our picture. We must now contemplate the big picture, and in doing so we confront the great silence. When astronomers measured the rate of cosmic expansion, they found something that shook the foundations of science. The expansion is not slowing down. It is speeding up. The balloon is being inflated faster and faster. This is impossible unless there is a something, an invisible, unknown energy embedded in the fabric of space itself that is actively pushing the universe apart. We call this force dark energy. We cannot see it. We cannot measure it in a lab. We do not know what it is. We only know it exists because we see its effect. It is winning the tug of war against gravity, accelerating the cosmos toward a cold, dark and empty future. And the mystery does not end there. For decades we have known that the stuff we see, the stars, the planets, the gas, you and me, is not enough. When we look at how fast galaxies spin, they spin so quickly they should fly apart. The gravity of the stars we see is not strong enough to hold them together. When we look at how galaxies move within clusters, they are also moving too fast. The only way these structures can exist, the only way the cosmic web could have formed in the first place, is if there is a massive invisible something providing the extra gravity. We call this dark matter. Like dark energy, we cannot see it. It does not interact with light in any way. It is a ghost in the machine, a silent, invisible scaffold that holds the visible universe together. Now we can finally see the true big picture. The user's analogy of a dark ocean is perfect. All the light we see, all the stars and galaxies, all the glowing filaments of the cosmic web, this is not the universe. This is just the 5%. It is the shimmering, sparkling foam on the surface of a vast, dark, cold, and impossibly deep ocean. This ocean is the true universe. This ocean is 95% of reality. The water of the ocean, the deep, heavy, unseen current that shapes the flow and gives the waves their structure, is dark matter. The ocean itself, the mysterious uniform energy that is causing the entire ocean to swell and expand, pushing all the waves further and further apart, is dark energy. This is the great silence. It is not just the physical quiet of the voids between the galaxies, it is the overwhelming, profound silence of the 95% of reality that does not and cannot speak to us. We are tiny, bright, normal matter creatures floating on a tiny raft of visible light, surrounded by an ocean of mystery. We can see the effects of this ocean. We see the waves, galaxies held together by its currents, dark matter, and we see the shorelines, distant galaxies rushing away from us, driven by its expansion, dark energy. But the ocean itself remains dark. It remains silent. Our entire cosmic journey from a small planet to the grandest structure of the cosmic web has delivered us to this final humbling realization. We are the foam on the surface of an unknown and perhaps unknowable sea. And that sea, silent, dark and vast, is the real universe. We began this journey together as a traveller, a symbolic explorer we called Atlas, venturing out from our home. We imagined leaving this quiet corner of space, this small planet orbiting a single star. Our journey took us far. We left our solar system and travelled into the vast spiralling arms of our home galaxy, the Milky Way. We looked back at its shimmering centre, a place of ancient stars and profound mystery. But we did not stop there. We pushed outward beyond our own galaxy into the deep dark space between. We found ourselves in a kingdom of galaxies. We drifted through our own small cosmic family, the local group, and watched our great neighbour, the Andromeda Galaxy, spiral in the distance. We kept going past countless other islands of light, each one containing billions of stars and worlds. We travelled across the unimaginable emptiness of the great cosmic voids, vast stretches of near total silence. We finally arrived at the largest structure of all the cosmic web. We saw the universe as it truly is, a vast glittering network of filaments and clusters, with all of known reality hanging within it like jewels on a thread. We went as far as we could go to the very edge of the visible universe, looking back at the oldest light, the faint echo of creation itself. It was a journey of almost infinite scale, and now it is time to come home. Let your mind reverse that journey. Pull back from the edge of time, from the faint ancient light. Leave the cosmic web behind. Feel yourself drifting across those silent, empty voids. We are moving faster now, heading for a familiar cluster. We enter the local group and see Andromeda swell in our vision, a beautiful massive spiral. But it is not our home. We drift past it, searching for a familiar band of light. And there it is, the Milky Way, our galaxy. We sink back into its welcoming arms, crossing the vast distances between the stars. We are no longer in the dense, bright centre. We are seeking our own quiet neighbourhood, a peaceful place in the suburbs of the galaxy. We find our way to the gentle Orion arm, and nestled within it we find a single familiar yellow star, our Sun. We travel toward it past the giant planets of gas and ice standing guard in the outer system. We move inward, past the red desert of Mars and toward a small precious marble of blue, white and green, our home, Earth. We float down through the high, thin atmosphere past the soft veils of cloud. We drift down over the dark oceans and sleeping continents down to your city, your neighborhood, your home. We travel into this very room, right to the place where you are resting. The entire universe with all its galaxies and wonders has led us back to this single quiet moment. Back to you. Here is the final most important truth of our journey. You are not just living in the universe, you are the universe. That vastness we just explored is not separate from you. The atoms that make up your body, the very carbon in your breath, the iron in your blood, the calcium in your bones, every single piece of you was forged in the fiery heart of a star that lived and died long ago right here in this Milky Way. That ancient star exploded, scattering its elements across space. Over billions of years, those elements drifted, gathered, and reformed. They built our sun, they built this planet, and they built you. Our imaginary traveler Atlas was a piece of some other distant star system, in exactly the same way you are a piece of this star system. You are the physical matter of the cosmos gathered together for a short, precious time and given the gift of awareness. You are the universe's way of thinking, of feeling, of wondering about itself. As you feel the gentle pull of sleep, hold on to this feeling. You are not small, you are not separate, you are a part of this grand, silent, and beautiful cosmic story. The universe is not just out there, a cold, distant place to be seen through a telescope. It is right here. It is inside you in every breath you take. You're made of stardust, and in your dreams you are returning to the stars. Sleep well. Good night.